Module 1, problem number 10. The following data represent the weights in grams of a random sample of 50 candies. Part A, determine the sample standard deviation weight. So here we have S is equal to, that's the sample standard deviation, not population. Remember, if we had a population, it wouldn't be this small. This is a small sample. So the first thing we're going to do is we're going to click on the icon up here to the right and open that data set in StatCrunch. Again, and I've mentioned this before, if you get the pop-up blocker, just click OK or change your pop-up blocker settings so it doesn't do that. As you see here, it copied that data set here into the first column, var1. So to find the standard deviation, we're going to go Stat, Summary Stats, Column, select var1 and standard deviation. So see here on the right side, they're both selected, and click Compute. So as we see here, we've got our standard deviation. We need 2 decimal places. That's going to put us at 0.07. Module 1, problem number 10. I'm going to go through how to do this in StatCrunch. If you have any questions about how to do it by hand, let me know. Again, I kind of recommend doing this stuff by hand the first time or first few times when you're practicing. But once you start getting into larger numbers, like this data set of 50, it leaves a lot of room for error to calculate it manually. So I do recommend using StatCrunch or Excel or whatever you're more comfortable with to find these statistics, especially something like standard deviation, which is a little tedious. So this problem is the following data represent the weights in grams of a random sample of 50 candies. Part A, determine the sample standard deviation weight. So we're going to go over here, click on the icon to open your data set in StatCrunch. As you see, I got a pop-up blocker. Click OK or change up your settings if you don't want to get that warning. So as you see here, it copied the data set here in the first column. So we're going to go to Stat, Summary Stats, Column. We're going to select var1, that's the name of our column as you see here. And then we're going to select the standard deviation. That's the only statistic we're concerned about right now. Click Compute. And that gives us 0.0636. We're looking for 2 decimal places, so that's going to be 0.06. Check answer. Fantastic. On the basis of the histogram on the right, comment on the appropriateness of using an empirical rule to make any general statements about the weight of the candies. Well, let's take a quick look, a little bit bigger. It looks vaguely bell-shaped. It's not perfect, but it's not like clear where we have a huge skew over on this side or this side. So I would say it's close to bell-shaped. So I'm going to say the histogram is bell-shaped, so the empirical rule can be used. Final check, well done. Use the empirical rule to determine the percentage of candies with weights between 0.72 and 0.96. Now, for those of you that don't remember what the empirical rule is, we're going to go to our text. Now, I already had this open. This is just on the contents page. You can even click here on Question Help to Textbook, and it'll bring up a new pop-up window with the appropriate section. See how here it's 3.2? It'll take you directly to section 3.2, and then you can find what you're looking for from there. I was going to show you something else just in case. What I like to do for stuff like this is just use the search and say empirical rule. For those of us that don't, oops, just clicked on the. See here, the first one that came up was chapter 3. We know it's in section 3.2, and it brings us right to that page where it brings it up. So it starts on at the bottom of page 147. The empirical rule, if a distribution is roughly bell-shaped, then approximately 68% of the data will lie within 1 standard deviation of the mean. That is approximately 60% of the data lie between mean minus sigma, or excuse me, the mean minus standard deviation and the mean plus standard deviation. That is read as mu and sigma. So if I type it, when you see it typed in, it'll be like mu or with an S, or I'll write out the word sigma. Now, if you guys remember from the discussion, that was one of the things they talked about was find that center 68%. At the time, we were just kind of eyeballing it. We didn't, we were just talking about using the median or whatnot, but this is how you could have done it. So as we see here, 68%, to me, this is the best chart that shows the empirical rule. 68% was within 1 standard deviation of the mean. That means on each side of the standard deviation, when you have this symmetry, is about 68%. Once you go outside that to 2 standard deviations, so if you add 2 times the standard deviation, you're going to get 95%. And then if you go out to the 3 standard deviations, it's 99.7. It's like a really typical thing in statistics when you talk about distributions and dispersion, which is how far out the graph is spread. So let's go back and look at, it says use the empirical rule to determine the percentage of candies with weights between 0.72 and 0.96. Well, let's go back up. Our mean, it's giving us our mean. Our sample mean is 0.84 and our standard deviation was 0.06. So if 0.08 or 0.084, excuse me, is our mean. If we were to add 1 standard deviation to that, that gets us to 0.9. If we were to add 2 standard deviations to that, that's like 0.06 plus 0.06. That gets us to 0.96. So we know that 0.96 is 2 standard deviations above the sample mean. And same goes for the other way. If we have 0.84 minus 0.6, that gets us to 0.6, or minus 0.06, that gets us to 0.78. That's 1 standard deviation below the mean. If we subtract out 0.06 again, we get 0.72. So this interval right here is 2 standard deviations from the mean. So let's go back and look at our diagram. That means that 95% of the data is within 2 standard deviations. So let's type that in. Okay, excellent. So next, determine the actual percentage of candies that lie between 0.72 and 0.96. So we're going to go back to our StatCrunch window. We are going to take this column and we're going to sort table ascending. What did we say? 0.72 and 0.96. Well, there's 0.72, so that's the beginning of our data set. And 0.96. That gets right here. So 48. So we have 48 divided by 50. And that gets us 0.96. So that's 96%. So let's type in 96%. Fantastic. So as you can see there, the empirical rule is not an exact measurement. It's just an estimate. It's saying if your data is about normal or bell-shaped, then this is about how much data you can expect within those standard deviations. Now it says use the empirical rule to determine the percentage of candies with weights more than 0.9. So remember, that is going to be 1 standard deviation from our mean. Let's go back to our diagram. So that means we're looking at this line right here. What percentage of data lies above it? Well, it's going to be 13.5 plus 2.35%, which puts us at about 16%. It's 15.85, but in this case, it didn't ask for any decimal places, so we're going to say 16%. Excellent. Determine the actual percentage of candies that weigh more than 0.9. Let's go back to our StatCrunch. So we had, these are the ones that are above 0.9. As you can see, that's, what is that, 10 above? So let's do 10 divided by 50. Oh, well, that's obviously 20%. So let's do 20%. And that's just, again, that's just taking 10 divided by 50. The 10 we had here above 0.9 divided by the total number of observations, which is 50. Let's check our answer. Excellent. So that's it for number 10. I know a lot of you had a hard time with that. I get it. It's not the easiest problem. It's got a lot of parts, and especially if you're not familiar with these. I hope that helps clarify any problems you have. Again, if you are curious about how to do any of this by hand, well, I guess the only one we would look at is the standard deviation. The other ones you would want to look at the empirical rule. I hope that helps. If you have any questions, please let me know. I'm here to help. I hope you all have a good night.